A very good morning to all my dear students. Welcome to your science class. So today we are going to start a new chapter, that is chapter number 12, electric currents and circuits. So in this module we are going to study about various components of torch, what electric current is, what electric circuit is, what electric switch is, and what do you understand by the electric conductors and insulators? So, starting up with the chapter, first of all, I would like to tell you all that as we see that our lives are so much dependent on electricity, as you see that in our home, refrigerator, television, microwave, your mobile phones and your laptops, your computers, so many things are running on electricity. So students, as you can see that in the picture, that nowadays so many electrical appliances has came into the market, which has reduced the men labor. As you can see that in the ancient times, when you will talk to your grandparents, and they will tell you that in their time they used to grind the masalas and whatever they need, they used to grind it manually on the mortar and pestle. But nowadays, just in a click, you will get the masalas, whatever you want, you will get it done, you will get it grind in just a click. So students, electricity has made our life so much easier, and we are so much dependent on electricity. So as we can see through this picture that electricity are very much important in so many sectors. And here, as you can see that for running cars, for giving supply in the headlights, and for running microwave, for ironing your clothes, for running refrigerators, and for lightening the bulb, and for running television, for charging your mobile phones and laptops, and to run the drill machines. What is required? Electricity is required. And as you can see that the factories have very large machines, and these machines works on electricity. So students, electricity plays a very important role in our life. So here we are going to study about what actually electric current is. So students, I will take you to a small story. Here, as you can see that Ramesh and Sunana are talking to each other and looking at the weather, and suddenly the thunderstorm striked. And as you can see that the lightning, it's a very the thunder and lightning is there, and the weather is very cloudy, and it is about to rain, and suddenly the current goes off. So what do? They call their mother and said, Mama, it's very dark. So the mother brought the torch, and she was about to on when she was about to on the torch to lighten up the room. What she observed, that she opened the battery. As she was unable to switch on the torch, she opened the battery, and she saw that, as you must have observed at your home, in your television's remote and your air conditioner remotes, you must have seen that negative and positive signs are there in the at the ends, and the positive terminal has the upper uplifted cap like structure. That portion will be, that end will be considered as the positive terminal, and the disc like end will be considered as the negative terminal. So students, here I would like to tell you one thing, that the one unit of cell is called cell, and when the cells are arranged in series, when they are attached together, they will be considered as battery. So students, as you can see that when the current goes, and your inverter works, so in that battery gives the power. In the absence of electricity supply, draw electricity from batteries. So students, the same way here itself, as you can see that the arrangement of the potentials are negative and positive and positive. So students, the torch wasn't glowing. So the mother has corrected the terminals, and the torch and the bulb in the torch has lighted up. So students, as you can see that the bulb in the torch is small, and the bulbs which are there at your home, in your rooms, are bigger in size, but their construction is almost similar. And now students, we will see that electricity comes through the power cell. So it is an alternative method, alternative source of getting electricity. All right, students. So here is the internal structure of the cell. So here I will not go in so much detail. The only thing I would like to tell you here is that inside the electric cell, a rod made up of graphite, and graphite is a form of carbon. And now you will ask, ma'am, what actually carbon is? See students, if you have ever been to a chemistry lab, or if you have ever seen your elder brother reading a periodic table, and in that periodic table 118 elements are there, and they are classified on the basis of their properties in a table. And so among these, carbon is one of the element among 118 elements, and it is a non-metal, and it is the only non-metal which conducts electricity. So here graphite is used as the anode, as a positive terminal, and as you can see that the carbon electrode acts as the cathode, and and the zinc casing is acting as an anode. This carbon rod is acting as a cathode, and the zinc casing is acting as anode. And as you can see that the protective covering is there. If you will cut your the cell you are having of Duracell and Everyday, if you will cut it, you will get to see this structure in the internals, in its internal portion. So the main thing I would like to tell you here is the graphite rod will act as the cathode, and the zinc casing will act as anode. So students, moving further, these structures also have some functions in it, like ammonium chloride is an electrolyte, is a jelly like structure which keeps the cell which is resistant towards the dryness. So students, here you will have to put more light on the cathode and anode. So students, moving on, this terminal which is uplifted will be considered as the positive terminal, and which is a disc-like structure will be considered as the negative terminal. So students, electric cells are also present in other forms as well. You do have cadmium cells which are rechargeable. You do have disc-like cells which you use in the hand clock. So students, moving on further. Now we will see what actually electric bulb is. Every one of you have seen the electric bulbs at your home, or you must have seen at many places electric bulbs are used, and nowadays CFL are being used. So students, how electric bulbs are made. So as we have studied in just the previous slide, that electric cell is a source of electricity, and this bulb consumes that electricity. As you can see that this is the glass case in which filament is there. We are going to study it in detail in the further slides, and here I would like to show you that these are the two terminals, positive and the negative terminal. This thin filament is molded on two thick wires, and these wires are drawn down in this section, and hence this filament works on the principle of the filaments get heated and the bulb is blown. So I will explain you the working of electric bulb in the further slides. So here the bottom of the bulb is made up of metal and is rod in shape. So students, here I would like to show you that this is a thin filament. When this filament is heated, the when electricity is passed through it, the filament get heated, and when it get heated, the bulb glows. And student, as you can see that the filament is molded on the two thick wires, and these thick wires are drawn, one is up to here and the other one is up to the last. And now this filament is, the thin filament is made up of tungsten. Why it is made up of tungsten? Why it is not made up of some other element? Because student, the melting point of tungsten element is very high. So when the filament get heated, it does not burns very easily. And then in the glass case, inside the glass case, a vacuum is created, because as you know that burning takes place in the form in the presence of oxygen. You must have seen in the junior classes, you must have done an experiment in which you have kept a candle, and after that you must have covered it with the glass jar, and then all of a sudden when the oxygen supply stops, the candle stops burning. So this principle is also used here, that when the vacuum is created, the filament will not easily burn. So this is the internal structure of the bulb. So students, moving on further, filament. This is the filament, as I have shown you. This gets heated and this bulb start to glow. A metal wire is an electric bulb which glows white hot when electric current is passed through it. It is called filament. Now students, what actually current is? Students, as I have told you that the flow of charge, when the charge flows in a closed circuit, is considered as electric current. So students, electric current is a form of energy, that is electrical energy, which gets converted into heat and light energy. When gets converted into heat and light energy, when it flows through an electric bulb. So students, as you can see that the wires acts as the transport. It transports the charge from one place to another, and when the charge flows through the wire, through the metal, so the electricity flows through it, and the source shows that the electricity when the source glows, when the source lighten up, so we see that the electricity is passing through a circuit. So students, I will tell you now that as I'm taking a name of circuit, what makes circuit. So students, as you can see here, you will require a cell, you will require wires, and you will require a medium. So students, as you can see here, that the battery, the wires are attached to the battery in such a way that the positive terminal and the negative terminal, the wires are attached, and these wires are then attached to the is connected to the bulb, and as you can see that the attachment, so the bulb start to glow. So students, what do you require to make a circuit? You need a source, you need a medium, and you need something to transport, and then you need a detector by which you can detect that the electric current is flowing through a circuit. So students, I will show you that if the arrangement changes, then what will happen? As you can see students, let's connect the positive of the cell with the minus sign, and the minus sign of the cell with the plus sign. Then too the bulb will glow. Okay students, this type of arrangement, when both terminals of the power cell are connected to terminal of the bulb, is called electric circuit. So students, you can see it here, that is a dry cell and a bulb is connected, and here you can see that they are connected, and this is a switch, and you can see that this makes a circuit. Alright students, so I'll show you the different arrangement of wires. As you can see in the first picture, when the when the wires are connected in such a way that the circuit is closed, there is no break in the circuit, the bulb will glow. As you can see that the circuit is break, so the bulb will not glow. So this means that the charge is not flowing in this circuit. So students, we can conclude from this that current only flows in a closed loop. If a circuit is break, if a circuit is open from somewhere, the current will not flow, and hence the bulb will not glow. You can see in C figure the circuit is not closed, and as you can see that here also, and in E figure the circuit, both the terminals are attached to the same positive terminal. So here also the bulb is not glowing, and when you see that the reverse of the reverse arrangement, then the bulb will glow. Now students, you have often heard in your houses that we used to say, if the bulb is not working, if it is not functioning, when we switch on the light, if it is not, when we switch on the switch and it will not glow, what do we call? We call it that the bulb has fused. So students, what actually it is? When the filament breaks off. So this is known as fused bulb. Alright, when the filaments break, so due to overheating, when the filaments break, this is known as fused bulb. So moving on further students, we can say that till here, from electric cells electricity is generated, electric current flows through electric circuit through which electric devices operate. Now students, moving on further, as you can see that I have cut it down the wire from here, and now I will attach so many other materials and check whether the circuit will be closed, whether the charge will flow or not. So students, I have taken different materials. So in the first place, I have taken a metal key, and then I have observed that if I will introduce these, if I will connect these two terminals with the key E, then will the charge flow in the circuit? Yes, the charge will flow, as metal is the conductor of electricity. So charge will easily flow through the circuit and the bulb will glow, as you can see in this image. So students, in the further, I will use rubber, I will use iron nail, and I will use chalk, and I will use cloth piece, and I will use glass. So students, you will observe that if I will attach in such a way, if I will attach these materials, so only when the nail is attached, the bulb will glow, and when I will attach the other material, the bulb will not glow, as these material do not conduct electricity. The charge will not flow through these materials. So students, we can observe that when iron nail is introduced in the circuit, the bulb will glow. When rubber is introduced to the circuit, the current will not pass through it, as rubber cannot conduct electricity. It is an insulator. Cloth is an insulator. It does not carry, it does not allow the charge to pass through it. Alright, and when we attach silver spoon, the bulb will glow, as silver is a very good conductor of electricity, but we cannot use it in the home wiring because it is very expensive. Now I'll show you that when I have attached the nail, the bulb is glowing. When I have attached the rubber, the circuit breaks, as the eraser will not allow the charge to pass through the circuit. As you can see that in the circuit, if I have attached a cloth, the bulb will not glow because the charge will not flow, and here the circuit is break. So students, as you can see that if I have attached a silver spoon, the charge will flow and the circuit is closed, and hence the bulb will glow. So students, after these experiments, we can easily tell what are conductors and what are insulators. So students, the substances which allow the electricity, the electric charge to pass through them are termed as conductors, and the substance which do not allow the electric charge to pass through them are known as insulators. So students, the materials that allow the electric current to pass through them are called conductors. All metals, carbon in the form of graphite, salt solution, impure water, and some conductors. The materials that do not allow electric current to pass through them are called insulators. Wood, cotton, wool, plastic, rubber, mica, bakelite, ebonite, distilled water, and glass are some insulators. Alright students, so moving on further, as you can see here that the experiment you have done, the conclusion is noted down in this section. So iron nail, it is a conduct, as it is made up, iron is a metal, so it is a conductor and the bulb will glow. Rubber is an insulator, the bulb will not glow. The cloth is an insulator, the bulb will not glow. The silver is a very good conductor, so the bulb will glow. So student, I would like to tell one thing over here, that silver is a very good conductor. It is better than the copper. It has a better capacity to carry the charge than copper, but we use copper in the electric wiring in our home because it is quite cheap. It is quite affordable. So student, if I will say that if switches will not have discovered, the appliances would have run 24 hours. Students, आप अपने घर में जो आपके electrical appliances होते हैं, आप देखते होंगे कि जब आप स्विच ऑन करते हैं तब वो रन करते हैं, जब आप ऑफ करते हैं तो वो रन नहीं करते. This is because, student, an electric switch is a appliance which makes and breaks the circuit. Suppose, students, if I have on a switch, so the circuit will be completed. If I will off the switch, so the circuit will be break. And if the circuit will break, the appliance will ultimately stop. So this is the basic principle behind it. You must have seen at your homes and so many places. Now students, I can show you over here. You can make a homemade torch by, you can take a bulb. This portion is known as switch. I have taken a pin, and in that 2 copper tag boards have been taken on the thermocol. I have nailed it, and then it will be considered as a switch, and the wiring I have provided, and this is the electric cell. In this way you can make the torch and you can make the bulb glow. And here, as you can see how you can make the electric switch by on the thermocol sheet. If you can just take the 2 tag boards and you will connect it with the pin, then if you will attach the pin, if you will close the circuit, then the current will flow. If you will remove this pin, the current will not flow. The circuit will be break, and hence the bulb will stop to glow. So students, thank you for listening. Hope you have understood the chapter electric current and circuits. So you are at the point where you can tell what actually electric current is, what you must have understood, what is the role of switch, how you can make it. You can simply make electric switch by taking the 2 tag board pins and one other pin made up of metal, and if you will connect it, if you will close it, the switch will be on. If you will remove it, if you will break the circuit, the bulb will stop to glow. So in this way, so students, you are at the point where you can you must have understood what are the conductors, what are the insulators. Substances which allow electricity to pass through them are the conductors, and the substances which do not allow electric current to pass through them are the insulators. I have given the examples as well, how to make a circuit, and how to, as I have shown you in the school as well, I have shown you that how to make the circuit. So students, hope you have understood the chapter. Thank you for listening, students. Read this chapter twice.